Okay, so we learned 20 polyatomic ion, but most of them are not listed there. So if we see phosphate, phosphate is not here. If we see chromate, that is not here. So assume all other ionic compounds which is not listed here are what? Insoluble. This is how we are deciding the solubility rule. One more time. All alkali metals, all group 1 metals, if you see sodium nitrate or sodium chloride, sodium phosphate, with any one, because there is no tie-up here, with any anion, with any polyatomic ion, they are soluble. All ammonium, all acetate, all chloride, all nitrate are also soluble. But in case of halides, fluorides are insoluble. It is not listed here, okay? If it is chloride, bromide, iodide, most of them are soluble except these three. When they connected with these three metals, they will be insoluble. Sulfate also same thing. If they connected with any of this metal, they are considered as insoluble. Then you got a compound which is not here. Say for example, you got zinc sulfide. You got zinc sulfide. Is zinc in here? On the first column, is there any zinc? Is there any sulfide? No, so that will be what? Insoluble. We'll give another example, okay? If you have calcium phosphate, Ca3PO4 twice. Look, calcium. Is calcium here? No. Is phosphate here? No, so that is what? Insoluble. Another example, if you have potassium chloride. Look, potassium, all group 1s are what? Soluble. You don't need to worry about who it is coming with because all alkali metal compounds are soluble. So this will be what? Soluble. This is how we are deciding it. Question. Yes. So if it is calcium chloride, look at the chloride. Is there any calcium here? Is there any calcium in insoluble list? No. So that is what? Soluble. Calcium chloride will be soluble. But if it is silver chloride, what happened? Insoluble. Because if halogens, chloride, bromide, iodide, when they connect with these metals, that salt will become insoluble. That ionic compound will become insoluble. I would say salt because all ionic compounds are called salt. That is a common name because they all have salty taste. Okay, let's try. So you wrote this one? Yeah. Okay, let's try the example. We are going to decide how we can see whether there is a reaction or no reaction. Okay. Now, you are given zinc sulfate with strontium chloride. There are two ionic compounds given. First step, swap the metal. You don't need to look any rules for that. You are just swapping them. You don't need to look the reactivity rule, activity series. That is only for single replacement. Okay. So, zinc will go with the chlorine. What is the formula for zinc chloride? What is the formula for zinc chloride? Zinc is charge of what? 2 and chloride is charge -1. So the formula will be CnCl2. Okay, next one. Strontium will go with what? Sulfate. So strontium is +2, sulfate is +2, so we need 1 each. So first complete the reaction. Okay. Before you balance, if it is not balanced, before you balance, you have to check their state, whether they are aqueous or soluble or not. Zinc chloride. Is there any zinc listed here? No. Is there any chloride listed here? Yes. Is chloride linked to zinc? No. So zinc chloride will be what? Soluble. So I would go write AQ. Okay, next one is strontium sulfate. Strontium sulfate. Sulfate are here, but unfortunately, if it is linked to SR2, we will consider them as insoluble. So we can say that is a precipitate. So you can write or down arrow or S. So now there is a solid. That is a condition. We need to get a precipitate. We got a precipitate. So this is a reaction now. Okay, if it is a reaction, you have to make sure that is balanced. Is it balanced now? Yeah. It's already balanced. Okay, let's try the next one. I'll give you 1 second to try. After that, I will do it. Okay, you have sodium sulfate and potassium chloride. Swap the metal and see what are the products are forming. Okay, K will go with the sulfate, so formula will be what? What? K2 SO4 plus Na will go with the Cl will be what? NaCl. Okay, before we balance the equation, don't waste time balancing it. You have to check whether there is a solid substance or not. Okay, potassium is group 1. All alkali metals are what? Soluble. You go write AQ there. And sodium is also what? Soluble. So there are 2 AQ. So this will not happen. So you can cross them out and write it. It is no reaction. For your AOL, you don't need to write the right part. Okay, you can just directly say that is a no reaction. But it is okay to write like this if you wanted to. Okay, why it is no reaction? Because there is no precipitate. For a double replacement reaction to happen, we need 1 precipitate. You will not get 2 precipitate. That is another condition, okay? You will only get 1 precipitate. Here both of them are liquids, or we can say not liquid. They are soluble in water, so they will be in aqueous state. We will consider there is no change we can visible to. There is no indicators there to show that is a reaction. Okay, let's try the next one. Aluminum chloride with what? Sodium carbonate. Aluminum chloride with the sodium carbonate. Just try it. Why you are waiting for me? Got it? Okay, sodium will go with the chlorine. What is the formula? NaCl. Okay. And aluminum will go with the carbonate. Formula will be? What is the charge of aluminum? 3 and carbonate -2. Crisscross them. You will get Al2CO3 3. Al2CO3 thrice. What is the next step? Not balancing. You have to check the solubility rules, okay? Sodium chloride. Now we don't need to check the formula. We are sheet. We know that all sodiums are what? All group 1s are what? Soluble. So write AQ there. Next one is aluminum carbonate. Look at the rules. Is there any aluminum in group, first table? No. First box, there is no aluminum listed there. Is there any carbonate listed there? No. So, if there is nothing listed there, we have to assume that compounds are insoluble. So, that is a reaction because we got a solid substance. Okay, now it is a reaction. You are responsible for Balancing it. Okay, go ahead and balance it. Yes.
So basically, a double replacement reaction needs to have one solid product?
Yes.
Okay.
Double replacement reaction need to have one solid product. Then only we can say that is a reaction. There are some exceptions, but as of now, we will go like this. Okay? Don't worry about that things. You will take care of that in your future. Okay. Now, there are 3 chlorine, 1 chlorine, 1 carbonate, 3 carbonate. How will you balance this? Okay, polyatomic ion first. Go. Okay, you will put 3 in front of Na2. Okay, that makes sodium into how many? So you will put 6 here. So you have 6 chlorine. So what times 3 is 6? 2. And check whether aluminum is also balanced. It will automatically balance if you balance all other polyatomic ion. Otherwise you have to make that balanced. Good? How do you feel about it out of 5? 5, 4, 5, 4. Is there any 0? No? What? 4. Okay. So now let's do the practice. There are 5 questions. Boys, there are 5 questions. I'm going to do these 3. You will do 2. Or I will do 2, you will do 3.
You do 3.
You do? Okay. Let's do it together, okay? First 3 we will do it together. Second, last 2 you will do by yourself. And I will go over it, okay? Let's start. Lithium nitrate. Lithium nitrate. Lithium is in group 1. Nitrate is in, nitrate, what is the charge of nitrate? -1. So formula will be? Yeah, write that. LiNO3. And it says solutions there, but all double replacement reaction. Remember, the given will be always aqueous solution. You will get only solution. You will not get solid for reaction. Reaction will always happen in liquid state. Reason, to make that faster, we will always dissolve in water. So write AQ. And sodium chlorate. Formula will be what? NaClO3. And that is also AQ. Okay, now we are doing what? We will swap them. We will swap the metals. Double replacement. Sodium will go with the nitrate. Lithium will go with the chlorate. Write the product. What is the product? Lithium chloride. I need the formula. LiClO3. And what is the next one? NaNO3. Okay, what is the next step? Check the solubility rule. Okay, solubility rule. You can check it here. All group 1s are what? Alkali metals are soluble. So both of them are what? Soluble. Okay, so I'm going to give you a tip. Whenever you see in your reactant both the metals, if both the metals are alkali metal, you don't need to worry about writing formula for the products. You can go directly write what? No reaction. So whenever you see both the givens are 0 group, sorry, not 0 group, first group, alkali metals, we will assume that as a no reaction. What happened, Ashes? Okay, let's try the next one. Ammonium carbonate and zinc chloride solutions are combined. Ammonium carbonate and zinc chloride solutions are combined. Okay, I need the formula for ammonium carbonate. NH4 Yeah, we need it twice and
CO3.
CO3. And we said everything should be aqueous for double replacement. The beginning reactants must be. And it says here too, solution. Okay, next one is what? Zinc chloride. So formula will be CnCl2. Okay, now what is the next step? Swap them. There is a metal and ammonium is not a metal, but we know that there is a positive compound. So that will swap. Always positive will replace positive. Okay, the product will be what? Ammonium will go with the chlorine. I need the formula for ammonium chloride. NH4 Cl, because both of them have charge 1 each. And what will be the second product? CnCO3. Okay, now what is the next step? Check the solubility and decide whether there is a reaction, whether there is a solid or not. Ammonium is listed under soluble. All ammonium compounds are what? Soluble. So you will go write AQ there. And zinc carbonate, check, is there any zinc here? First column, first box. No zinc. And is there any carbonate there? So we will do what? We will assume all other ionic compounds are insoluble. So you will write that as insoluble. You have to write S or a down arrow. Okay, now we know that this is a reaction. So you are responsible for doing what? Balancing. Okay, so now you need to balance it. Okay, so there are 2 chlorine, 1 chlorine, 2 ammonium, 1 ammonium. We'll start with the polyatomic ion. How many ammonium here? 2. There is only 1. So you will put 2 there. Are you happy? Is everything balanced?
Yeah.
Yes, that's it. We'll go to the next question. Number 3. Silver nitrate and strontium chloride solutions are combined. Silver nitrate. Yeah, we know the formula. We wrote it multiple times. AgNO3. And you had to write AQ, showing it is a solution, aqueous solution. And strontium chloride. Strontium is in group 2. So what is the charge? 2. So chloride is -1. When you flip, crisscross them, formula will be SrCl2. Okay. Now, going to write what? Products. You are swapping the metals. First element. Always replace the first element. Okay, Ag will go with what? Cl. Someone give me the formula. AgCl. And Sr will go with NO3. Formula? Sr what? NO3 twice. Okay, next step. Checking the solubility role to decide whether there is a precipitate or not. Okay, AgCl. Cl is here, Ag is here, which is connected to Ag. If it is AgCl, that will be what? Insoluble. So we got a precipitate. So remember, if you have one precipitate, the other one will be definitely what? AQ. But we can check it. Nitrate is listed here as soluble. Nothing is connected to nitrate. So all nitrates are what? Soluble. Okay, now we have to balance the equation because we know that this is a reaction. How will you balance? We'll balance polyatomic ion first. There are 2 nitrates here, 1 nitrate here. So how many? Which number? Where to multiply? AgNO3 need to multiply it by what? 2. Okay, now Ag become 2, so I'm going to multiply Ag with the 2. So that will be good now. Is it good? Okay. So I did 3 questions, Nikhil. Now it is your turn. Go do it. 4 and 5.